So my name is Andrea. I work for GeoSolutions. We are an open source company based in Italy that maintains a GeoServer, MapStore, GeoNode, and also provides services for GeoNetwork. We are an open company in more than one way: open source, open standards, and open services. Where are we with Inspire supporting GeoServer? So regarding Inspire, in this presentation, I'm focusing on publishing complex data. So the application schema that Inspire may or may not mandate. It has been watered down a little bit during the last few years. They figured out that complex schemas are sometimes too complex for people, and they also provided a flattened down JSON approach with very, very ugly attribute names like Rod 1, Rod 2, Rod 3, Rod 4. But generally speaking, to provide complex models, you need complex features, something that can embed in one object subarrays, subfeatures, maps, and whatnot. And so GeoServer provides compliance in more than one way in this regard. There are the list of all the services that we provide, but in this presentation, we focus on the complex features aspect. So a complex feature in GeoServer is provided by the application schema extension. What is the idea? Somebody mandates a certain XML application schema for publishing. The XML application schema contains the description of all the data types that you need to publish, their relationships, their structure, and so on. And it's typically pretty complicated. And they basically tell you, you have to publish data abiding to this structure. That's how we achieve interoperability, because if everyone publishes the road description or their borehole description the same way, there is a shared understanding of what the attribute means and so on. So it kind of relieves you from providing detailed metadata because you are following a well-known structure. Application schema basically starts from your database with multiple tables. On the other end, it has the GML schema that are the target, and it provides mapping between your complex database structure and the complex GML schema that you need to achieve through mapping. The plugin has no special schema requirement, like you can target whatever complex application schema you like, and you can have whatever database structure you like at the end, meaning the mapping in between can be very sophisticated because it has to cater for all possible ideas. And so this is one tiny example of stations, observations, and parameters for weather stations, I suppose. And I have 3 tables in the database, and through the mapping towards the application schema, I end up generating that complex GML output. How do I do these mapping files? Well, in practice, most of the time by hand, painfully. There is also a user interface called Hail, and there is a plugin for an old version of Hail, version 3.5, that can be used to go from database structure to target application schema. And there you have a visual editor to do the mappings. It helps a bit. So this is more or less how it looks like. It's more or less what you would expect. On one side, the input structure, on the other side, the output structure. And then you have relationships, renaming attributes, collecting arrays, and stuff like that to go from your relational structure to the 3 information structure that you have in a GML complex feature. Now, this is a pain. I'll be very honest. It's a royal pain to do. So we started working on new approaches to do that. So again, our use case, it's a simple didactical example, but you have the idea. A station provides observation and measurement through certain parameters, and we have the observations at a certain time. The temperature is this value, or the wind speed is that value. So classic agronometric central. So what are the moving parts? Well, of course, I have my data model in the database on one side, and my data storage on one side, the relational database, or something else. Could be MongoDB, could be Elasticsearch, could be complex JSON documents on one side. On the other side, I have my target data model, which is typically a complex UML model or an equivalent XML schema. Nowadays, it could be JSON-LD, but you have a target structure that you need to map. We have the publishing, which could be complex GML or complex GeoJSON, and we have app schema sitting in the middle doing everything on its own. We believe that this is kind of the original sin of app schema. It's trying to do too much. That's what's making it so complicated. We have a very complex mapping. The engine has to not only to do the mapping forwards, it has to do the mapping backwards, because when you query on a certain property, it has to map it backwards to the equivalent property in the right table in the relational structure of your database and so on. So it has to do a lot of work. The application schema mapping file is a massive XML document that, well, yeah, it's basically mapping table by table, attribute by attribute, back and forth the information. And yeah, GML schemas are basically leading the dance. It's normal. I mean, application schema, it's called it like that because it was designed to allow building GML abiding to a certain application schema to start with. That was the goal. And we think that this is just too hard for many. And having complex features shouldn't start with writing one massive XML schema document because you might not even need it. So we figured out we could do things in a slightly different way. Do we have a relational data storage and we wanted to provide complex features in output? We created, for that case, a plugin called Smart Data Loader. The Smart Data Loader, let me see if I can, okay. The Smart Data Loader looks at your database structure and basically follows the foreign keys and says, oh, okay, this table is related to that table. It's a one-to-many, it's a one-to-one, it's a many-to-many, and tries to figure out a complex schema, target complex schema for you automatically so that you don't have to invent a new application schema. It's already in your data. And then it basically generates that target schema and the application schema mapping for you. So it's kind of a wizard for application schema. From a user interface point of view, you start with your relational structure and you say, oh, the root entity in my relational structure is this table. And from there, it follows the foreign keys and says, oh, okay, so you have this nested object, that nested object, and so on and so on. And it generates all the mappings for you. At that point, you're already able to publish proper complex structure based on your own data structure without having to, you know, map onto something that some scientist has designed somewhere else, or that you might have had to do. And this is already good enough to publish complex structures without getting crazy. So yeah, the screenshot. I already told you everything here. And so yeah, this is what comes out after a few points and clicks in the user interface. So it says, oh, okay, so we have this meta station feature with this connected to a meta observation, which is connected to a meta parameter, and so on and so on. It figured it out from the database structure. It didn't have any target to reach. And it's already dumping the data that you have in your database without any hassle in terms of configuration. However, you might actually want to go towards a target structure, right? You might be happy here and say, this is my structure. This is what I use internally. I don't care about the rest of the world. But you could say, no, wait, I actually wanted to do something more. So as I said, Smart Data Loader helps you publish complex features without all the trouble of going through application schema. It does it for you. And then there is another module, which is called features templating, which has a separate job. Given an original structure, it could be simple, it could be complex, it could be a JSON document, it could be coming from Mongo or Elasticsearch, allow me to map it to an output structure of my design. But again, without having to start necessarily from application schema structures. So no XML schema for you, or not necessarily XML schema. In fact, in many situations that we have seen with research institutes, they want to do a different structure depending on whether they are doing JSON, JSON-LD, or GML. It's the same data model, but they want to structure it in a slightly different way depending on the actual output encoding. And so feature templating was born to exactly do that. Actually, nowadays we also have an HTML output format so that you can do also HTML representation of your data, whatever way you like. So this is, again, our use case. And this is a GeoJSON template. So the idea is I go from that database structure to the GeoJSON structure that I want. Again, this is a complex structure. You can see that inside properties, I have observations, which is an array which contains complex objects and so on. So it's not your flat GeoJSON, but it's a complex one. The idea behind the features templating is that you basically declare the structure that you want in output in the output language itself. So I wanted to write a GeoJSON, I write a GeoJSON template for it. It's reminiscent of variable substitution in Python, if you are familiar with it, right? To some extent. It's just that when you are following relationships, it's actually able to do that and go and jump to the nested properties and so on. In some cases, in this structure, you can also see that we are calling functions. So for example, this one has a location property, which is a 2WKT of a position property that I have in my database. This is something that we do to support JSON-LD. In JSON-LD, you cannot have geometries, like in GeoJSON. They have to be strings. Don't ask me why, I'm not the expert. As I said, I'm doing it on behalf of another person, but in JSON-LD, it's forbidden to have arrays of arrays. And so what happens? Well, the template is processed as the data flows in, so it's a streaming process, and every attribute is replaced from the original structure to the one that you want in output. This process is actually also understood on the other way around. If I'm querying the property observation.timestamp, this machinery knows that it maps back to the time property in the observations table. And it just looks at the template to determine that. So you only have to think about mapping forward. It's going to do the back mapping for you. You can create multiple templates for a single layer in various formats, XML, HTML, and JSON. And you edit them directly in GeoServer in a tiny editor. And you can also live test the templates as you edit them. So you are doing your own thing, and then you can ask it, okay, let's run the template against the data source, see what comes out, see if it's actually matching what I want. So it's really practical. In terms of which template to use for which feature, there is not a one-to-one relationship. As I said, we might want to have different templates for different output formats and providing a slightly different structure. Point in case, if I'm doing GeoJSON, I need to do the classic GeoJSON geometry. But if I'm doing JSON-LD, I need to turn it into WKT instead. It shouldn't be a geometry because that would break JSON-LD compliance. And so I can have a matching mechanism saying, oh, if the service is WMS and the operation is get feature info and the layer is that one, then use this template. Otherwise, use another one. Some use cases, and then I'm done. First use case from the Bureau de la Recherche Géologique et Minéraire. Merci. From France. They have 1 million boreholes. They make them available through WFS and OGC API features. and they want to have the boreholes described both as simple features and as complex features. In addition to that, they also want to do JSON-LD. And with the feature templating and smart data loader, we help them to achieve all various output formats without requiring a double degree in software engineering to do that. Filtering using SQL is supported, as I said, so you can specify one filter against the output property. That's the nice thing. You are not filtering against the original structure because, I mean, the user doesn't see it. It should be transparent. You are filtering against the output properties, and the machinery maps it back transparently to the original structure and runs a SQL query or a JSON query if we are talking about MongoDB and friends. We also have one other use case from BRGM, another database. It's called BDLISA, and they want to use it from QGIS. And we stumbled into a little bit of hiccup. In order to parse complex features, QGIS needs a valid XML schema to do that. So what do? We also allowed to map the schemas themselves. So you can do a template also for the schemas and say, this is my output schema for this structure. And then it's fully covered, like the function is not leaking anymore. The client sees consistently my output structure in GML and the schema in a consistent way. This is one example of the request that are being run, heavily redacted. It looks like we are working for CIA. Another use case, it's from NPRA, which is the Norwegian authority that manages the roads. In this case, they are starting from a complex JSON structure in a MongoDB, and they want to go out with complex GML instead. And so again, the feature templating is mapping from the semi-randomized structure of the JSON towards a very strict and rigid GML structure in the output and backwards. And that's it.